also going to go over this example, which is in your book. It's a good example, and it's kind of fitting right now, given all the tension that's going on. So, does political party affiliation depend on age? Well, actually, that question, we know the answer, and the answer is yes. All right? So not even looking at this data, which happens to be just fictitious data, but just looking at the actual research done on political party affiliation. For the most part, younger people tend to vote Democrat and older people vote Republican, except in Utah, where most everybody votes Republican. But, obviously what goes on nationally does not necessarily mean that that's going to be true for each and every state, right? But at least, we know that as a general rule, young people tend to vote Democrat and older people tend to vote Republican. All right, so let's say you want to know on your campus. Okay, so what do people, who do they affiliate with? But you're not just asking whether they affiliate with Republican or Democrat. You want to know, does it depend on age? So you have a second variable. So here's variable 1. You're going to ask them, Republican or Democrat. You're going to ask who they vote for. And you're going to have observations, right? You're going to observe whether they are Republican or Democrat. The second variable is you're going to ask them how old they are. So you're also going to get observations on another variable. So here are your two variables, 2 levels or 2 categories of political party and 4 categories or levels of age. Notice how age has been grouped into categories. So age normally is ratio as our level of measurement, but by grouping them into these non-overlapping categories, it now becomes ordinal. Okay, and these are simply the number of people out of 400 who fell into each of these category combinations, also called cells. Okay? Again, they are your observed frequencies because this is what you actually observed. Now, what about the expected frequencies? Good news, you don't have to calculate them. All right, SPSS will do that for you. But you have to remember how SPSS is calculating these expected frequencies. The expected frequencies are calculated as if, okay, that's important, as if the 2 variables are independent of each other. In other words, to get the expected frequencies, SPSS is going to look at this data, okay, the observed frequencies, and it's going to say, okay, based on your observations, here is what you should have seen, all right, and I don't have these expected frequencies marked down here, so you just have to pretend that there are numbers popping up here. These would be the frequencies you should have expected if, in fact, age and political party affiliation are not related to each other, okay? So that's kind of nice that you don't have to calculate those by hand. Now, as far as our hypotheses are concerned, HO, null, none, and nothing, will say that there's no difference between your observed frequencies and what was calculated, the expected frequencies. All right, now remember, the expected frequencies are calculated as if there is no relationship. So if your observations are the same as the expected frequencies, that means these frequencies also imply no relationship, right? Because these are no relationship and these equal these. So you're going to conclude there's no relationship, probably. On the other hand, if the observed frequencies are not the same, that means the 2 variables are related, probably. So you can either say variable A depends on variable B, or B depends on A, or you might say that your 2 variables are contingent on one another, which means, A is contingent on B, or vice versa. All of those would be appropriate ways of expressing these results. Okay,